Docker Compose can also work great as a development tool. Not only can Docker Compose pull and run public Docker images, but it can also build an image from a Docker file and run it alongside other containers. Imagine a scenario where you have an application with a dependency service like a database. Before Docker, a developer would need to download, install, and configure a database for local development. With Docker and Docker Compose, you can create a Docker Compose file to build your application into a Docker image and run it with a database in another container. The best part is that this is just code within your application's codebase. Any developer can pull the code and just run Docker Compose up to set up a full working environment. In an earlier chapter, we wrote a simple Ruby web application that used a Redis key value store to keep track of page views. When we demonstrated this earlier, we had to build our image, launch it, and then launch the Redis container. We also had to make sure that the application container could access the Redis container via the network. This becomes much easier with Docker Compose. Let's take another look at our application and Docker file. This code should look familiar, as it's code from Chapter 4. This Sinatra application simply increments a number in Redis and writes the new value in a small HTML document. We see here that we're using the DNS name Redis to connect to our Redis instance. This means that we'll want to name our service Redis in our Docker Compose YAML file. Let's take a look at the Docker file. This is also the same Docker file from the Chapter 4 web application lesson. Once again, we're starting with Alpine Linux, installing Ruby and Sinatra, adding our code, exposing ports, and setting Ruby as our entry point. Instead of building our application into an image from the command line, we're going to build it from a Docker Compose YAML file. Here, we'll define our Ruby application as the first service in our Docker Compose file. We'll call our service counter for obvious reasons. Instead of specifying an image this time, we use the build attribute and give it the current working directory as the value. The path specified here tells Docker Compose where the Docker file to build is. Just like before, we want the ports mapped so that we can access them on the Docker host. We'd also like our application to start up after Redis, so we specify the Redis service as a dependency of our built application. For Redis, we simply specify the image name. Since we're naming our Redis service Redis, the Ruby application can access it by that name. Let's run it. Instead of using Docker build, we'll just run Docker Compose up. Docker Compose is now building our Docker file. We now see in the output that our application is up and running, as well as Redis. We can test out our web application in the browser via the Docker host at port 4567. And if we refresh the page, we'll see that the number is incremented in Redis. So it looks like our web application is successfully connected to our Redis instance. Even with a larger, more complex application, Docker Compose allows us to have a simple, shareable, and reproducible dev environment for our code.